So now the guidance portion of lab exercise 1. So this is, not everything that you need. You're going to have to go out and you're going to have to look at the docs for the different functions that you need to use and read about C and all that. But this should give you something to go on at least. So, background on putChar LCD. The C function putChar LCD places the single character corresponding to its argument on the LCD screen. Its prototype is this. So it returns an integer. putChar LCD is what it's called. Its argument is a single integer, which is called C inside of the function. Where both the input parameter and the return value are the character to be sent to the display. A character constant is an integer written as one character within single quotes, such as x. For example, calls to putChar might be putChar single quotes m. So if you were to save or assign what putChar returns to a variable, you could do so. Or you could just call putChar without assigning what it returns to any specific variable. To write both parts of your program, you will also need to know how the escape sequences used in the putChar LCD function affect the LCD screen. This concerns the important matter of input-output, which we will consider in detail later. For now, the following table explains the escape sequences. So there are 4 escape sequences that we're going to use. Clear the display, move cursor left 1 space, move cursor to the start of line 1, move cursor to the start of the next line. So the escape is common in a lot of programming, so get used to seeing this as an escape sequence, recognizing that as an escape sequence. What it means is the character after this is special. It represents something and not just F, for instance, or B or V. Not just what the character says, but it's some sort of command, something of importance. So, dissecting a C program. So that was a little bit of putChar LCD for you. And then I'm going to give you guys some stuff on C for the next while. So, dissecting a C program. This lab requires the use of several aspects of the C programming language. It's kind of a crash course. In this section, some of that is outlined, but of course, Kernahan Ritchie or some other C textbook is required for sufficient understanding. We begin by writing a simple C program that sums loop indices and proceeds to unpack, and then we proceed to unpack its meaning. So here is the program, and we're going to kind of walk through this program. What I'm going to do is I'm just going to describe it, just looking at it, and then there is text that follows this, and I encourage you to read through that. So we start with including the library. So these are comments up here. You can either do comments like this, where you do a slash and an asterisk, and then you close it with an asterisk and then a slash, or you can do a double slash. I'll use both. Okay, so and that just comments the rest of the line. Good. So this comment, it says include libraries. So this is where you're going to include the libraries that we need. So for this C program, I'm going to include the standard input-output header file for the standard C library, from the standard C library, which is going to give us the printf function, which we need to do almost anything. So we'll include that, and then we're going to declare function prototypes. So a function prototype is something that declares what the function should return, what type of variable the function should return. It declares the name of the function, and it declares the types of the variables that are the types of arguments that the function should take. The way we're going to structure our programs, we will declare our function prototypes up here above the main function. Now, there are other ways of doing it, but this is sort of a convention that is, I think, a good convention, and it's pretty common to see, although not universally so. The next is to define external or global variables, and this is actually something I will go to the text for here. This description is I think, pretty important to kind of slow down for. So, yes. So external or global variables are those defined above main. These variables are defined once and can be accessed by every function that declares it with extern. So if, for instance, you had defined a global variable above the main as being like x, then inside of another function, you could say extern x at the top of that function, and you'd be able to access the global x variable. A similar but distinct object is the symbolic constant, which is what we are using in this example program, defined by this hashtag define, pound define, as with n in our program. So that's what we're using. A difference, and there are some subtle other differences as well, but a difference is that symbolic constants need not be declared within a function. So they're available throughout the rest of the program. We conventionally capitalize symbolic constants. So n is capitalized there because it's a symbolic constant. Okay, now we go back to our program. Okay, and we've got to define functions. And the first function that we define is main, and that's another convention that we have. We don't have to define main first, but that's a convention that we will use in this class. Always define main first, and then our other functions. Every function every C program has to have a main function in it. So this is sort of a key aspect of C. When a C program runs, it starts with the beginning of its main program, its main function. And then you can call other functions from inside of it, as we will do, but main is always run at the top. So main returns an int. So it's actually, main always returns an int, and there are some rules around what the significance of those return values are. If it returns 0, it means it exited properly. If it returns a number that's not 0, then those are error codes, and they should correspond to something that happened. So if you call a C program from, say, the command line or some other program, you're going to get back from that C program a number. Okay, so an int. And that integer is going to be 0 if everything worked well, and then it's going to be something else if it did not. So that's something to keep in mind. You can also pass arguments to it. So say you called a C program from the command line, then you would be passing arguments to it in this way. And I'm not going to go into detail on that. We're not going to need that feature in this class, but it's good to be aware of that. So that's why that's the declaration there and for the definition. So the definition then proceeds. So we open a brace. So for a function, we have this opening brace, and then it closes on the next page. So we won't see that close yet. You might see sometimes people will write the brace on the next line. Totally fine. It's just good to be consistent. So brace on the same line, brace on the next line. Same for loops. Just sort of be consistent and you're fine. Okay, so we declare a static integer x of 10. So this is inside of main. Now we have a new scope of variables. Okay, so inside of each function, you live in your own world of variables, and the variables are called automatic variables because they only exist inside that function. Now, each time you call that function, typically it's going to get a new automatic variable. However, if you declare it to be static, then it's going to use the same address in memory, and they don't go away in between function calls. Very important difference, and we're going to talk about for this program. It actually runs differently because of that. So, and then static integer I is going to be an index for us, and we're going to do a little for loop, and we're going to print some things. We're going to do a little bit of math, write a little function for some math stuff, and we're going to print some stuff. Do a for loop, which is another structure that we should be familiar with. So for is among several of the sort of common familiar structures that you should see in C. It's a for loop, and it uses this very specific syntax here. So what you do here is you use parentheses to define sort of 4 blocks. So the first block here is the initialization block. So what it does is you can define a variable in there, for instance, like I equals 0, initializes I to be 0, assigns 0 to I. The next block, I less than n, is the condition that it evaluates each time before running your loop here. This is the sort of the code block or the statements that you want to have inside your loop that get repeated. Before it runs that, it's going to check that this condition is met. So if I is less than n, so after it initializes, I will be 0, and therefore I will be less than n as long as n is greater than 0. So yeah. And so it'll do that check. So then there's the condition. So this was the initialization. I is less than n. That's the condition. And then it's going to run this code block. Okay, it's going to run this block. So then it goes into it's inside the braces here. And this is statements or whatever you have in there, and then it ends by doing the I++, and we're going to talk a lot about I++, but this is the increment. Okay, so that's it's gonna add 1 to I each time around the loop. It never goes back to init. It goes back to, it does these 3. And then it goes back up to condition again, checks the condition, goes back through, checks the condition, and goes back through, checks the condition. That's how it runs. And inside this loop, we are going to be assigning, so x of I is going to be a specific element of the x array, which was initialized to be an integer array of size 10 up here when it was declared. So the ith element is going to be equal to the sum of I. So sum is a function that we're writing below. We'll look at in a minute. But whatever it returns, we're going to assign to x of I. We're going to print that as a digit. So printf. The syntax is this is a formatting string here. %d is to print a digit, a floating point number, and that should or an integer, and it should just print that character to the console. If I is less than n minus 1, so before the last time through, then print a comma, and otherwise, else, print a period. So if it's the last time through, then print a period. And then after you've gone through that loop, that n times, then 0 is the return value, so say that it exited properly. But you don't strictly have to return 0, but it's good practice to get used to that. Okay, let's look at our sum function here, because it's actually kind of interesting. So what we do is we hand it an integer, and we're going to return an integer. And it initializes the variable y inside of the sum function to be 0. And then what it does is it takes y, and it says, okay, y is equal to whatever y was. So the first time through, y is going to be equal to 0, plus whatever you hand it. So the first time through, you hand it I equals 0, so 0 plus 0 is 0, so not very interesting. And that's why it prints this first 0. The second time through, I will be equal to 1, and it will be 0 plus 1, and then the it will print a 1. And then the next time through, it will print 1 plus now the input, or the argument, is going to be 2. The index is 2, so 1 plus 2 is 3. And then the index is 3, so 3 plus 3 is 6. And the index is 4, so 6 plus 4 is 10. And then it ends. So there's that last period after all of these commas. Now, if something was bothering you, which I hope it was, let's actually dig into that. So y, you might think, well, y is 0 every time through, so why wouldn't it just return x every time? So y is always 0 until you add it to x, so then y would be x, returns x. But since we have a static integer y, then it doesn't actually, once it's been initialized, it doesn't, once it's been pre-allocated or initialized, it doesn't get overwritten with this default value. So once we added 1 to it, it's stored it as 1. So y doesn't get wiped away every time this function gets called. So it's a little bit different than we're used to. And it's not that every variable is like that in C. It's just the ones that we declare to be static are like that. So I think that is all I had for you for this. Yeah. So I want to also walk through some other aspects of C here quickly. Actually, you know what? I'm gonna split this up. I gotta go, so I'm gonna split this up into one more section on the guidance for lap 1, and so this will just be that first little bit, and then we'll do execution control and some of these other topics, C topics that I wanted to talk about in the next lecture. So keep them shorter bites. All right. I'll see you guys soon.